underside of all of the 450 beams, which were the deepest beams in this instance. And there was reason for that, and I'll illustrate that reason as we go through this again here. I would therefore like to upload the drawing of yesterday again so that I can do some explanation, and I'll also go through and illustrate some of the other aspects as well. So just could you guys please confirm that this drawing is showing on the screen? That we have quantity surveying 3, concrete structure, reinforced concrete shown on the screen.
Yes,
please. Okay, thank you. Please just remember that when I do share something, I cannot see when someone has typed anything in, hence me asking that you please say something from your side. Okay, right. So I will now be looking at when we look at this drawing that we have here, and I would now be looking at the beams, but with the beams, and as you would have seen in the notes that I had uploaded, I do collects for the beams. The reason for the collects of the beams would be is because when we have with beams we would have beams of similar sizes, and that we could then the same way that we did the brickwork in first year, we do the collects for that, the same that we did for the basements that we did here. We do collects because because we would have a number of similar sized items, and in this instance it would be similar sized beams. And we would therefore look at getting the collects for these beams. And as we look at the beams, and we look at the beam sizes that we were given, the beams in the beam schedule, you'll notice that 1A, you can follow me on the drawing. I've drawn the line 1A, 1B, 1C, 3A, 3B, and 3C. All of those are of size 220 by 300. And there's one thing that we need to understand. Unlike with what we do as quantity surveyors or being in construction, when we measure the horizontal first and the depth last, engineers, civil engineers, structural engineers, they generally do their drawings in the opposite way. But this drawing was not done by an engineer, it was done by a construction individual. Hence, the dimensions here are given with the depth as the last size. Engineers generally give the depth as the first size, with the width being the last size. So it would be illustrated to you. Generally, when we're dealing with a beam, the beam, as you guys would have done in structures and concrete, the beam is at its strongest when we have, as in this instance, we have 220 by 300. The beam would be at its strongest with a size like that. If it was like that, this beam would be stronger than this one. You agree with that? Hence, we're saying that your deepest section generally be the depth of every beam that we see here. Right. So when looking at the beam, at the beams and that we need to be drawing here, I would then be looking at calculating the overall length of each of the respective sides. Right. But I will now be starting not with 1A, 1B, 1C. I'll be starting with my vertical beams first. The reason for that is, it is where my columns meet up with the underside of my deepest beam to my beams A1, B1, C1, and D1. When I look at those, I will then write my beams, my collects, and I will start out by writing in my collects. I will start out and say A, full stop, and I'll write the size of the beam. But when writing the size of the beam, instead of me now writing the full size of the beam, I will be writing the size of the beams. I would, instead of writing the size of the beams out in full, I would deduct the thickness of the slab from my beam. Why is that? This is purely because the concrete strength of my beams would be the same as that of my slab. And why would that be? It is because when we cast the beams and the slabs, we cast them all in one go. I said yesterday that the reinforcement joins all these different members together. So we could have the columns that would be there, the columns would be cast, they would all be in their place, but the beams and the slabs would generally be of the same strength, structural strength, meaning that when they get cast, we would cast the slabs and the beams all in one go. So I can therefore cut the beam, or just give the measurement of the beam to the underside of the slab. And when I do that, when I say to the underside of the slab, all I am doing is that when I will be measuring my slab, I will ensure that there are no deductions. I will ensure that I measure my slab from the one end of my drawing, from there to there, all on the outside. I'll measure my slab. So, meaning that I will measure the slab over everything, and my beams would stop on the underside of my slab. So when I now look at my collects, I'll start out with A. It'll be 220 by 300. If you follow me on the if you follow me on the notes that I've also sent through, it'll be 220 by 300, but then in brackets I indicate that this comes from the deepest beam of 450. You guys with me? It comes from the deepest beam of 450, and I will show that. That there be 150, and then this here be 300. So I will measure my beams to there. At least try and get that line straight. Then I'm drawing with a mouse here. At least try and get that line straight. So in essence, that would then be my 450. The 450 beam would be there overall. But I'm now saying that it's 220, she's there, 220 by 300, and I will only measure my beam to there. Having said that, I've shown on this side that from there, my slab will be measured from there. But you remember I said yesterday that the beam size would include for the slab that goes over it. So I say that it's 220 by 300 in brackets coming from my 450 deep beam. So what do? We indicated yesterday that this dimension here is 7 meter 500. But that 7 meter 500 takes me to the center of my beam, and then I would then have to add on my 110 on either side, of my beam, and that is exactly what we've done. If you follow there, it's 500, and we add 220, which is the beam thickness, times half, times 2, we add 2 20, and I say to you that I will now have 7, 7, 20 multiplied by 3. And the multiply by 3 would be for that beam, and that beam. Follow me now. You might ask me, sir, why do you not include beam A1? Anybody would like to know why we do not include A1 in that dimension? We do not include A1 for the simple reason that A1 is not just a straight beam as the others. A1, and I will draw A1 separately on the side. A1 have that shape. A1 would have that shape. Can everybody see that shape for A1? And I need for you to speak with me. I cannot see what you type. I need for you to speak with me. Can everybody see that shape for A1 that I've drawn there? Who cannot see that shape for A1? Please, guys, it's important that you talk to me.
We can see this shape.
When I share, can you see that shape?
Yes.
Right. Is there anyone else that can see that shape? For A1?
Yes, sir. I can see the shape.
Okay. Okay. I know that we have other people here that cannot see the shape. Is there anybody that cannot see the shape? Remember that it's nothing if you cannot see the shape. It is fully understood if you cannot see that shape. I will explain why we have that shape. You can remember that we said that we measure the columns to where? To the underside of the deepest beam, right? All in agreement. Okay. Now, what is the shape of the column at A1 and C1? What is the shape of that column? L-shaped, right? It's L-shaped. So, meaning that that column sits there. And there. Here's my L-shaped column. Second one. Right. So because that L-shaped column sits there, if I take this beam through to there, I take this beam through to there, I would be leaving out that section of that beam. And I would then do an injustice to my measurements. If we have a look over here, you can all see that this beam, that beam there, is lower than that beam there. Can you all see that? Right? That beam is lower. So meaning that when I measure, I need to go around the corner there. I need to include it up to there as in order for me to ensure that I take care of that section over there, which I would be leaving out, which I would not have measured, or which I would have to come back and do an extra over measurement over there to include that section there. Can we see what I'm talking about? Guys, remember, I cannot see your hand. I cannot see what you're typing because I'm sharing the screen. I need for you to talk with me. I need for you to tell me that yes, you are good with that, or no, you do not understand what it is that I'm talking about. No comment. Can I assume again that we are all understanding, that you are with me in this? Or is my assumption incorrect? Okay, so I take it that we are all with me on this one. So if we have a look at that, that is the reason why I have only included B1, C1, and D1 in my dimension there of what belongs together. So meaning that I will then, because this column, L-shaped column, is a 340 by 340, I will now then have to add 120 over there, and 120 over there to my beam, to this overall length of 7, 7, 20. So if you have a look at my dimensions, I then say I have 7, 7, 20, and I'll then add 2 by 120, and that overall length of that would then be 7, 9, 6, 0, which I would add to my 23, 1, 6, 0, and my overall length for my beams of 220 by 450 would therefore be 31.12. All happy with the dimensions that I've just shown there? Right? Okay. Now I'll be going through to my beams in between. My beams in between, I will now look at 1A, 1B, 1C, 3A, 3B, and 3C. And when I look at those three beams, I then start out 220 by 150. Why 150? Because the slab thickness is 300, this is 150, and the beam overall size is 300. So I will be working with the 150 that goes on underneath. The 150 that goes underneath for those beams. I will then have in between. I will then have when I look at my beam sizes, I see that I have 4 meters, 5 meters, and 5 meters. But those all take me to the center of the beams. Hello, yes?
Do we always use the slab size when we come to the other beam?
We always remember that the beam, all our beams are measured through the slab. But because for the sake of, as I said earlier, whereby I said that the beam and the slabs will generally have the same concrete strength, we can therefore split this up. It is purely to make life easy for ourselves. It's purely to make life easy for ourselves. If I have to do a cross section of the slab, I would do this. I would do that. But this beam would be from there. It would be the reinforcement for that beam. The reinforcement for that beam would be, but the reinforcement for the slab would then go through. It would go through, and it would be mixed with, because it goes in between my beams. But we'll measure for the beams, we only measure to there, and we'll take the overall dimension, deduct the slab thickness, and we only work the section below there. The reason for that purely is to make our lives easier when we measure the slab overall. So we don't measure in between and use up lots of time, because we will always be pushed for time when we measure our slabs and beams. So what we do, we make life easy, so we work to the underside of this beam, and we work for the slab we'll work through. Hence me saying that we will then say it is 220 by 150, and that will be coming from the 300 beam. So we will purely be working with that, even though we are telling them that the beam overall is 300 in depth. You got that? So now what we do, I'm first and foremost, I'm going to look at getting my dimension from there to there. You see that I've now included, I've gone to the outside of my beam, right? The outside of my slab. And we have that length. We've got that length as 14 to 20, something that we calculated yesterday. 14 to 20. So now I'll take that overall length of 14 to 20. I'll multiply that by 2. So it'll now be that side and this side, as well as that side. 14,220 times 2. But I will now, what is it that I want to calculate? I'm just going to clear this drawing here quickly, guys. It's a bit messed up. I'm just going to clear this drawing. Just need to. Okay. I'm just going to. What I will do now, I want to measure, only determine the length that being there, that being there, that being there, together with the other opposite end, there, there, and there. All with me. Now remember this line here. This line takes me to the outside there. That line takes me to the outside there. I have 28,440. So I will now deduct the 340 there times 2. I'll deduct the 220 over there times 2. The 220 over there times 2. And the 220 over there times 2. Is that clear? That will then leave me with everything in between. Leave me with that. That'll then leave me with that. That's exactly what I've done. Deducted the 340, deducted the 220 times 3, and multiplied all of those by 2. So I've deducted 2 meters, and that gives me an overall length of 26.4. Can we all see that? Yes or no?
So can I ask you a quick question?
Yes, sure.
Okay, so we deducted basically on top of those columns, right? On all sides of the horizontal beams.
Remember that my beams A1, B1, C1, and D1 went through. We measured them to the outer side of my structure.
Yeah, I was going to ask that, so you answered it. Thanks.
Okay. And we measured the rest in between. The rest of those beams in between. Okay. Everybody with me? So we see how we get the 26.44. Okay. Then for my beam 2A. 2A, we see the beam schedule tells us that 2A is 200 by 250. So I'll then say 200 by 100, and in brackets give the overall height depth of the beam of 250. Notice that I have a dimension of 4 meters from the center to the center, but that beam runs in between A1 and B1. So I need to deduct that section that is there and that section that is there. So I deduct half of my 220, which is the width of beam A1 and B1, times 2, it gives me, I'll then say 4 meters, deduct 220, that leaves me a dimension of 3.78. Is everybody with me on this? You can see where I get some dimensions. Okay.
Can you repeat that again, sir?
Okay. Right. I'll say, I'll start out with that 4 meter length of beam. Right? That 4 meter dimension that I'm given there. But that takes me to the center of that beam and that beam. But I need the dimension on the inside. I need that dimension. I've now found that if I could blow that up, I would have that and the 4 meter take me to there. And what's the size of this beam? And I can see here, the size of that beam is 220. So I need, because, and the dimension from there, that way, is 4 meters. 4 meters. So I want to deduct this section over there, which is, you can all see that? 110. What happens on the one side, on this side, also happens on the other side. So I need to deduct the 110 on this side and 110 on the other side. So from that 4 meters, I would be deducting difficult to write with this pen, with this mouse. I'll be deducting 220, and that leaves me 3780. Is that clear now?
Yes, sir.
Got that now?
Thank you.
Okay.
Yes, sir.
Right. That brings me to the end of my collects. End of my collection. When we do measure this, I'd like to take us back to the standard system. I'd like to take us back to the standard system. And what the standard system says. What have I done with my standard system now? Don't tell me that I have. I don't think that I have. In my standard system, I just need to find Formwork. Okay, I'm just going to go out of this, and then I will upload the standard system just to show to you exactly what it is that we are talking about here. When I go to my Formwork, when I look at Formwork, to slabs, beams, and stairs, you can all see what I've uploaded here, standard system. If I look at that, it says that the formwork to soffits or slabs and hoods exceeding 250 millimeter, those are for slabs. We'll look at that just now. But when I look at the formwork to my beams, the formwork to beams, it would be measured. It would be measured to indicate that my propping up would be not exceeding 1.5 meters, exceeding 1.5, not exceeding 3.5, and thereafter in stages of 1.5 meters. So what am I trying to say is, unlike what we've measured previously with the columns, the formwork to that, you would then look at indicating with different stages of which, from which we would be measuring the formwork here. So keep that in mind. I'll refer back to the standard system shortly whilst we go through and have a look at what it is that we need to measure here. Okay, I've not done my collects. I've done my collects. I've done my collects for my beams, and I will now use those same dimensions that I've indicated there to measure for my beams the reinforced concrete 20 MPa 19mm stone in slabs, beams, and inverted beams. And the reason for me saying slabs, beams, and inverted beams is because the standard system tells me that when I measure concrete, it tells me that when I measure concrete, in the classification of my concrete, as you can see over here, it says that the classification, it says that the components that we would measure is concrete is in surface blindings, surface beds cast in panels, footings, bases, underpinning. Then it says to us, it says slabs inclusive of beams and inverted beams. Hence me saying that in my description, reinforced concrete 20 MPa 19mm stone in slabs, beams, and inverted beams. Then I underline beams to indicate which component it is that I am measuring now. You see what the standard system shows me there. And I then have my same dimensions. Now, remember that what I've written in my collects, I will transfer those dimensions straight across to my dimension column. My first set of collects was 31.12. Those were for beams A1, B1, C1, and D1. Multiplied by my width of 0.22, multiplied by my depth of 0.3. But you might say to me, sir, but the beam is 450 deep. That is why in my collects, I've indicated that it is 300, and in brackets I've shown that it actually comes from the 450 deep beam. You with me? Then 26.22, 5.22, 5.15. I've not taken the dimension that I've written in brackets in my collect. Then I have 3.78, 5.2, 5.1. That is my reinforced concrete done and dusted. You've done all the hard work in your collects, arriving at the correct dimensions and the like. So when I, excuse me, then when I now come and I have to do the formwork, I then say formwork to sides and soffits of beams, including propping up, exceeding 1.5, not exceeding 3.5 meters high from bearing level. But where do I get that from? I go to my drawing and I indicate, I notice on my drawing, and I'm just going to upload that again to illustrate, show exactly what it is that I'm talking about. Why I can say that it's exceeding 1.5, not exceeding 3.5. Remember that this here, remember, I can find my cursor. Remember that this here now is my trying to make a B. And this here is my bearing level. This is the bearing level. This is the platform where my scaffolding would be placed. Remember that previously for my bearing level for my columns was over there. But my bearing level for my beams and my slab now changes to where the scaffolding would be placed for these beams here. So what is the height from here to there? It is 3 meter minus 450. That gives me 2550. And that takes me to the bracket or to the category of exceeding 1.5, not exceeding 3.5. You with me on that one? So that is where I get that category from, exceeding 1.5, not exceeding 3.5. And as I've shown you in the standard system, it says that formwork is measured not exceeding 1.5, exceeding 1.5, not exceeding 3.5, and thereafter in stages of 1.5 meters deep. Okay, so I take the standard system tells me I'll be jumping between these two guys. Let's be jumping between the standard system and my drawing here. The standard system tells me that in my formwork, if I look at the formwork and the formwork components, it says the formwork components would be walls, columns, beams, isolated beams, wall beams, slabs, hoods, stairs, shaft construction, and the like. Those are different components. So I'm not measuring the formwork to my beams, but I can measure the formwork to sides and soffits. Remember, all of this is purely for us to be saving time. So I am measuring formwork to sides and soffits. As if you follow on your drawing, you'll notice that I have highlighted, I've used colors in here. I set that A, which we calculated in our collects. A was a 220 by 300. B was 220 by 150, and C was 200 by 100. Now I'm saying to you, it's formwork to sides and soffits. The S and S is sides and soffits of beams. So what do? I add the total of that. It is purely to save myself plenty of time when dealing with this. You can, as I said, you can do it individually, but you're going to take a lot of time. And I also below that, I illustrate how I arrive at the length that I'm using as my formwork. So I say it's 220 plus 2 by 300 gives me 820. And if I look at A, it says my length that I had for A, 31.12 times 0.8. For B, which was 26.44, I add 220, which is my horizontal, and 2 times 150, which is 300. That gives me 520. I then have the length multiplied by the girth of that beam of 520. The same for C, which is 3.78, and I have 200 plus 2 by 100, which gives me a girth of 400 or 0.4. Are you with me in those dimensions that I have there? With me? I hear nothing. So I take it that you are taking in what I'm saying and that you are familiarizing yourself with what it is I'm saying. All with me? So can I continue? Okay. Right. That was for my beams. I'm ready to move over to slabs if you guys are good with me. Everybody silent. Right, so yes, Luyanda.
So sorry. Can I just please ask, when do we consider measuring working space
So God.
for formwork, if I'm not mistaken?
Okay, can you hold that thought? I will get back to that one. And I'm not sure, have I uploaded the rules pertaining to measuring concrete structures and working space? I can have a look if I've not.
Yes.
If I have not, then I will. But I will do the explanation on that one, on the working space separately. If you can just bear with me on that one. Just remind me to do that. Okay? But the working space we will measure we will measure, and I generally measure the working space right at the end when I measure it, but we can add it at over here as well. Okay.
All right.
So I will not bother myself too much with the working space for now. There's a simple explanation around the working space that I will show you guys. Right. Okay. Can I continue? Can I move on to the measuring of the slab?
Yes.
Okay. I will just clear this drawing here. I'll just clear this drawing here for the slab measurements, and so I just need to clear this. What have I done here? No. All this thing to save all of this. Guys, can you just bear with me while I just God, I just need to bring this drawing up again. But when we measure the slab, it is because we have now gone through and we have ensured that we do not, because we have ensured that we do not cover that we do not measure in between. We're actually making our lives very easy in that we will now measure the slab through. But one thing I need for you to remember is that you remember that I said that the beam goes through the slab, right? And with the beam going through the slab, at your ends, the beams that you have on the periphery of your structure, your beams 1A, 1B, 1C, 3A, 3B, 3C, A1 and D, A1 and D1. All those beams that are measured over the slab would still be beams. And I'm going to take you to the standard system that speaks to the formwork. The standard system that speaks to the formwork to edges of slabs that not exceeding 300 millimeters deep. Many people make the mistake of measuring the edge of that slab as an edge of slab. But in effect, and this is what I first want to show, I first want to upload the standard system to just illustrate exactly what it is that I'm talking about. Don't tell me that I have taken my standard system out again. Deleted standard system. Yeah. Apologies, guys. Computers are not my strong point. I come from before computers. Is there anything that you guys would like to discuss or talk about whilst I am searching for my Seems like I'm talking to myself again, so that's fine. Get used to that. Okay, got the standard system. Right. Good standard system. Okay, the standard system, when we're dealing with the slabs, with the formwork to slabs. Here we go. When we're dealing with formwork to slabs, we deal with formwork to soffits of solid slabs, hoods, and that it will be measured. You'll see there that it says formwork to soffits of solid slabs and hoods exceeding 250 millimeter thick shall be given separately in stages of 250 millimeter. Now, because the slab of ours is 150 millimeter thick, we do not have to indicate not exceeding 250 millimeters thick. We just measure that as formwork to soffits of slab. Also, when we're dealing with the formwork of the edges of our slabs, and in this instance, if I'll just do a drawing on here to show. I'll just do a drawing. I can't do it on here. My apologies. I'll have to do it in the PowerPoint where I can write it. It tells me that, and I will show here. Formwork to edges, rises, ends, and reveals. Formwork to edges, rises, ends, and reveals are measured in 250 millimeter only where they exceed 300 millimeters high. Where they do not exceed 300 millimeters high or wide, it is measured in meters. So, formwork to edges, remember that. I'll refer back to this again. If I now upload my drawing once again, and on my drawing here, over here you can see that we have, over here you can remember that we measured that beam to there. So when that edge, that little piece there, would not be an edge to slab, but it would be formwork to sides and soffits of beams, because my beam runs there, and there. But I will get to that now. I then say a reinforced concrete 20 MPa 19 millimeter stone in slabs, beams, and inverted beams. The same description that I had for my beams, but with the difference that I'm underlining my slabs. I'm underlining to show that I'm specifically dealing with my slab here. Now, if you ever look back, you'll notice that the strength of the concrete in the slab is the same as the strength of the concrete in the beam. I now use the example here where I say reinforced concrete and I say multiply by 0.15. The reason for that is because I will be using the same dimensions for the slab, for the concrete, and for the formwork. But with the difference that I'm now telling that the square meterage of the slab, I'll multiply by 0.15 to arrive at my volume of concrete that I need to do here. And then, formwork to soffit of slab, including propping up, exceeding 1.5, not exceeding 3.5 meters deep. Same formwork as per the standard system that says formwork to soffits from the propping up would be not exceeding 1.5, exceeding 1.5, not exceeding 3.5, exceeding 3.5, not exceeding 5 meters as my bearing level for my propping up from my bearing level. So the height we've ascertained from ground level or my bearing level to the underside of my slab will be 3 meters minus the 150. So the overall dimension that I have for my drawing is 14220 by 7720. Something that I've ascertained right at the beginning. So I'd say take my dimension overall, and I'm measuring my slab size. I am now measuring over from one side of my slab. What have I done? See it there for a while. But I've taken that from, if I look at my first floor plan, I've measured from the outside there, I've measured the outside over there. So that is 14220 times 7720. That is for the concrete as well as for the formwork. But if I look at the formwork, you'd notice in the formwork that I've already measured formwork for that, measured the formwork for that, measured the formwork for that, formwork for that, 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 that. Already measured the formwork to all of those. So in effect, what I will be doing now, I will be deducting the formwork to all the soffits of the beams. Not the formwork to the beams of the beams, but I'll be deducting where I have already measured formwork to the soffits of the beams. Does that make sense? I'm now saying deduct ditto. And in saying deduct ditto, my formwork measurements would now be purely for that section there, that section there, that section there, and that's that section there. That will be the formwork that would be left over when I say deduct ditto. So I'll take 31.12 times 0.22. That will be all the beam sizes, 26.44, 5.22, and 3.78 times 0.2. That is all the beam sizes because I've already measured the beams throughout, and that is what I will be deducting over there. Are you with me in that?
So can I ask a question?
Yes, William?
For the slab, you measure through the whole slab. What about that staircase that comes through the slab?
One of the things, good question there, William. Remember, one of the things that we said right at the onset is that we use the southern style of measuring. We measure through and we do the adjustments later on. So we're not concerned now. We measure as if we do not have any of those issues. Okay. So we are not concerned with that opening at the staircase because there's something else that happens over there. Right. So I'm just measuring everything through a slide. Can you remember in your first year when you measured, you did not deduct any windows and doors as you worked through when you did your brickwork? You remember that? You came back at the end and you did your windows. You came back at the end when you did your doors. For now, we are not bothered with that section. Okay? Right. So when we now go, I've now measured the concrete in my slab, I've measured the formwork to my slab, I've deducted where I've over measured the formwork to the slab, and now I will be measuring formwork to sides and soffits of beams as before. And that is purely for that section there. Only for that section there that I'm now measuring formwork to sides and soffits of beams. And the dimension in dealing with that, it takes me only my external dimensions. So it will be 14.22 times 2, 7.7 times 14.22 times 0.15 times 2, that side and this side, and then 7.72 by 0.15 times 2, this side and this side. So I'm purely doing the external dimensions, ensuring that I measure that under sides and soffits or beams. It is not to edge of slab. It will only be to an edge of slab or something like this, where there is no beam underneath. On the sketch, I've made a sketch on my drawing where I've illustrated that quickly. Guys, could I just have a 5-minute comfort break, please? I just need to relieve myself quickly. I'll be back here shortly. Is that okay? Just gonna pause the